Hello, Algebra 1. Today we are going to be completing our eliminations foldable. Now, it is called elimination because we're going to do exactly that. We're going to completely eliminate either the x or the y variable so that we can solve only one at a time. So remember, solving a system of equations is plural. It means we're solving two equations at the exact same time instead of just one. So we're going to take it step by step in three cases. Case number one is where we add the equations together. This will be the simplest of the three cases, so we're going to start there. And we're going to start with example number one. Example number one, we have negative 2x minus 3y equals negative 8. And we also have 2x plus 10y equals positive 8. So here's the trick. This is what we're looking for. We're looking for the same number for x and y, but both being positive and negative. So do you see how this is a positive 2 and this is a negative 2? This is exactly what we want, because when we add these together, positive 2 and negative 2, they add to make 0. So in other words, they cancel out. So we're going to add them just like you would kind of in elementary school. They're stacked on top of each other. So these two add to make 0. Negative 3 plus 10 would be 7y. And then negative 8 and positive 8 add to make 0 as well. And at this point, a lot of you are probably thinking this is a no solution. However, we can continue to solve for y. So to continue solving for y, I would divide by 7, and 0 divided by anything is still 0. So at this point, I've shown that y equals 0, but I still need to solve for x. So you can plug into either the top one or the bottom one. It doesn't matter. I like the bottom one because it's positive. So I'm going to start by plugging this in. So 2x plus 10. We just solved that our y is equal to 0 equals 8. Well, 10 times 0 would just be 0. So then I'm left with 2x equals 8. So therefore, x equals 4. Putting it all together, because our solution has to be an ordered pair. So our solution is 4, 0. All right, putting it all together. Let's try another one. Example number 2. Example number 2, we've got, let's put this down here. So this one's going to look like 6x minus 5y equals 1, and then 4x plus 5y equals 9. Now in this scenario, we want to look for, again, the exact same number, but with different signs. And I'm going to go ahead and try and tear this so that this will lay down for me a little bit better. Okay, so like I was saying, we're looking for the exact same number, but with different signs. So I'm looking at these two right here, positive 5 and negative 5. Those add to make 0, which is exactly what I want. So that's why we call elimination. We are eliminating the y. So 6 plus 4 gives me 10x. And then when I add these together, 1 plus 9 gives me 10. So I can see that x equals 1. But again, I'm not done, because I have to plug in now to solve for y. And it doesn't matter which one I plug into. I'm just going to choose the top. So 6 times 1. And then I forgot the minus 5y equals 1. 6 times 1 leaves us with 6. Subtract the 6 on both sides. So then I can see that y equals positive 1 as well. All right, so my solution would be 1, 1. As a reminder, if I'm going too fast, this is a video, so if you need to pause or stop it or rewind it at any point, you are free and encouraged to do so. So that's case number 1, where we're just adding them together. All right, case number 2. It gets a little bit more complicated. Case number 2 is where we have to multiply one equation by a number. We have to multiply one equation by a number. All right, so let's look at an example. Let's do an example of that. All right, example number 1. Let's try negative 6x minus 4y equals negative 2. There's our first equation. And then 12x plus 8y equals 4. Now, if I'm looking at this equation, 12 and negative 6 do not cancel. 8 and negative 4 do not cancel. However, if I were to make them the exact same number, like for example, if this were a negative 12, then they would cancel. Or if this was a negative 8, then these would cancel. So in order to make that happen, I'm going to multiply this top equation by 2, because that would give me negative 12 and positive 12 cancels out. So I'm going to multiply this entire equation by 2. Now you have to be careful, because when you do this, you have to distribute to all the pieces, right? So this becomes negative 12x minus 8y equals negative 4, because I also have to multiply the other side of the equal sign by 2. So that's my top equation, and then I'm going to rewrite the bottom equation so that you can see that that stays the same, and then we're ready to add them together. Well, negative 12 and positive 12 cancel out. Negative 8 and positive 8 cancel out, so I'm left with 0 on this side. Oh, and looky there, the 4's cancel out as well. So if 0 equals 0, does that make a true statement? It does. So since this is a true statement, we have infinite solutions. Infinite solutions. 0 equals 0 is a true statement. All right, that was number 3. Okay, let's try number 4. This one will actually have a solution for you. Okay, let's try negative 7x minus 12y equals 6. And 2x plus 4y equals negative 4. All right, now if we look at our options here, it would be really challenging to eliminate the x's, because a 2 doesn't multiply to make a 7. But if I look at my y's, I could multiply the 4 by something in order to make a 12. And that would be awesome if this was a positive 12, because then they would eliminate. So what number should I multiply this by to make 12? Hopefully you're saying 3. So we're going to multiply this bottom equation by 3. And don't forget, this has to distribute even to the other side of the equal sign. Students a lot of times forget about the other side. But remember, what we do to one side, we have to do to the other. Okay, so we're going to multiply. This creates a 6x plus 12y equals negative 12. And I'm going to rewrite the top equation for you. Just bringing that top equation down. And now I'm ready to add. All right, so 6 minus 7 is negative 1. 12 minus 12 gives us 0. And then negative 12 plus 6 is negative 6. So I can divide to see that x equals 6. All right, you know the drill. We're not done yet. Okay, so now I need to plug this in to solve for y. I'm really partial to the second equation because these are positives. So I'm going to plug that in. So I've got 2, and then 6 was my x value, plus 4y equals negative 4. All right, so this becomes 12. And then subtract the 12, which is negative 16. So y equals negative 4. All right, and then put it all together. My final answer is 6 comma negative 4. All right, looking good. Remember, the name of the game. The name of the game is elimination, and the only way that can happen is if the numbers are the same, but one's positive and one's negative. All right, you ready for case number 3? Case number 3 is the most challenging one because it requires the most work. So instead of multiplying one equation by a number, now I have to multiply both equations. By a number. And these will be different numbers. So different equations are going to require different numbers to multiply, and that's okay. Just as long as what we do to one side, we do to the other. All right, so I believe we're on example number 5. Let's put number 5 here at the top. All right, let's try. Let's do 6x minus 2y equals 12. Negative 4x minus 7y equals 17. Okay, so let's think about our options. If I want to eliminate x, what number could I make the 4 and the 6 so that they're the same, but I've got one positive and one negative? What number is a multiple of 4 and 6? The smallest one that I'm thinking of is 12. So I could multiply this by 3 to get 12, and I could multiply that to get 12. Or we could consider eliminating the y. What's the least common multiple between 7 and 2? You're probably thinking 14. So I could multiply this one by 2 to get 14, and I could multiply it by 7 to get 14. So it just kind of depends on what your preference is. I'm going to go for the x's because one's positive and one's negative already. If I eliminate the y, I would have to multiply by a negative at some point so that I would have one positive and one negative. So I'm going to go for x instead. So if I'm going to make these into 12s, then that would require me to multiply the top one by 2. And then the bottom one would require me to multiply by 3. Because again, I'm trying to make positive 12 and negative 12. Okay, so let's rewrite our new equation. So multiplying by positive 2, we've got 12x minus 4y equals 24. Then the bottom one I'm going to multiply by 3. So that's negative 12x minus 21y. And then 3 times 17 would be 51. No. 3 times be 21. Yeah, 51. Okay. All right. Making sure we got that. All right. Now, when we add that together, my x's eliminate, which is great. And then I add those, so that would be negative 25y, and that creates a 75. So therefore, I can see that my y is negative 3. All right, if you get stuck at any point, please hit pause or feel free to rewind so that you can go back and watch the video again. All right, so I still need to plug this in. So let's plug it into the top. So I've got 6x minus 2. My y is negative 3. All right, so I can see that that's going to make positive 6. Subtract the 6. x equals 1. So therefore, 1, negative 3 is my final answer. All right, looking good. Okay, we've got one more, and then we are done for the day. All right, number 6. Number 6, let's try 10x plus 6y equals 22. And negative 6x minus 5y equals negative 9. All right, so again, we want to think about what our options are. If I wanted to eliminate the x's, what's the least common multiple of 7 and 10? We don't have a whole lot of great options. 7 and 10, the least common multiple would probably be 70. What about 5 and 6? What's the least common multiple? What number could I multiply by to make them the same? So that one would, the least common multiple here is going to be 30. So I'm gonna go for eliminating our y's. And I already have a positive and a negative, which is great because you have to have positive negative for it to make 0. All right, so I'm going to multiply the top equation by 5. And I'm going to multiply the bottom equation by 6 because I'm trying to manipulate these to be positive 30 and negative 30. All right, so let's write our new equation. We've got 50x plus 30y equals 110. And the bottom equation, we've got negative 42x minus 30x equals negative 54. All right. Oh, that's not, I meant y. All right, there we go. That looks better. All right, so this is looking good, right? Because these two are going to add to make 0. So we're going to add those together. 50 minus 48 would be, or 42 makes 8x. And this leaves us with, I'm going to make sure I do this correctly, 56. So therefore, x equals 7. All right, we're almost there. Home stretch. All right, these numbers are a little bit smaller, so I'll use the bottom equation. So I've got negative 7 times positive 7, which gives me negative 49. Add the 49 to the other side, which would be 40. So y equals negative 8. All right, put it all together. Final answer, 7 comma negative 8. And that, my folks, is a wrap. Thank you for listening, and your homework assignment is going to be on Big Ideas Math, and I'll see you next week.